I want you to picture something that doesn't exist. No, really, imagine a number that, when multiplied by itself, gives you a negative result. Sounds impossible, right? Well, welcome to the world of imaginary numbers. But here's the thing. These imaginary concepts might just be the key to understanding the very fabric of our reality. But what exactly are imaginary numbers? Well, imagine you're a 16th century Italian mathematician named Girolamo Cardano. They formed the complex plane, a two-dimensional wonderland where numbers dance and spin. Fast forward to today and we use these imaginary numbers to describe everything from electrical circuits to quantum mechanics. Every point on this plane represents a complex number, a hybrid of real and imaginary parts. Now let's talk about pi. You probably know it as 3.14159, the ratio of a circle's circumference to its diameter. But pi is so much more than that. It shows up everywhere, in the equations describing light waves, in the statistical bell curve, even in the rhythm of our heartbeats. Some have even suggested that pi encodes the entire history and future of the universe. But here's where things get really interesting. There's an equation that brings together imaginary numbers, p, and another fundamental constant, e, the base of natural logarithms. It's called Euler's formula. But more than that, it reveals a deep connection between exponential growth, rotations, and waves. It's like a Swiss Army knife of mathematics cutting through the barriers between different fields. Now imagine for a moment the spiral of a nautilus shell. It's a perfect example of the golden ratio, often represented by the Greek letter phi. This ratio, approximately 1.618, shows up in art, architecture, and nature. But why? The answer lies in the Fibonacci sequence, 1, 1, 2, 3, 5, 8, 13, and so on, where each number is the sum of the two before it. As this sequence grows, the ratio between consecutive numbers approaches the golden ratio. It's a pattern of growth and proportion that nature seems to love, from the arrangement of leaves on a stem to the spiral arms of galaxies. But what about prime numbers? These indivisible integers are the atoms of arithmetic, the building blocks from which all other numbers are constructed. They're crucial in cryptography, forming the basis of the encryption that keeps our digital world secure. And that's not all. Primes show up in the most unexpected places. The life cycles of cicadas, for example, are often prime numbers of years. Some physicists even speculate that the fundamental particles of our universe might be organized according to prime number patterns. Could primes be nature's way of encoding information at the most fundamental level? Now let's consider an old idea with a new twist: the ether. In the 19th century, physicists imagined an invisible medium through which light waves traveled. This concept was eventually discarded, but what if we bring it back as an information field? Imagine the universe not as empty space, but as a field of potentials and choices. Every point in this field is a decision waiting to be made, a wave waiting to collapse into a particle. This ether becomes a stage for the interplay of duality, where every choice creates its opposite, and reality emerges from the balance. But to really understand this field, we need to go beyond complex numbers. Enter quaternions, four-dimensional numbers that can represent rotations in 3D space. They're the mathematical language of spacecraft orientation, computer graphics, and possibly the fabric of space-time itself. Quaternions give us a glimpse into higher dimensions. They show us how the universe might be folded in ways we can't directly perceive, and they bring us back to that fundamental idea: rotation. From the spin of electrons to the orbits of planets, rotation seems to be a key principle of existence. Now let's zoom out and look at the big picture. All these mathematical concepts, imaginary numbers, pi, primes, the golden ratio, they're not just abstract ideas. They're part of a recursive harmony that plays out across all scales of reality. From the fractal patterns of coastlines to the branching of trees, from the spiral of DNA to the shape of galaxies, we see the same mathematical themes repeating. It's as if the universe is a giant iterated function system, constantly folding and unfolding according to simple yet profound rules. But here's the kicker: none of this exists without an observer. In quantum mechanics, the act of observation collapses the wave function. determining the reality we experience. What if this principle extends to all levels of existence? You, the observer, are not separate from this mathematical symphony. You're an integral part of it. Every choice you make, every thought you think is part of this grand recursive algorithm we call reality. In a very real sense, you are the universe observing itself, collapsing infinite potential into concrete experience. So the next time you look at a spiral shell, or gaze at the night sky, or even just count on your fingers, remember, you're touching the invisible code of reality. From the imaginary to the infinite, from the prime to the transcendental, it's all connected. And you, yes you, are right at the center of it all, decoding the universe with every breath. But here's a final thought to keep you up at night. If reality is code, who or what is the programmer?